So we've got a new demo to show you, and this is using the LimeSDR Mini connected to an LMS8001 Companion Board, which is a frequency shifter that's specified for up to 10 gigahertz use. It's a 4-channel platform connected to the channel C input. We have a horn antenna, an X-band horn antenna, and to the rear of which we've just got a WR90 waveguide to SMA transition, and then the down-converted output, so the channel C output, is connected to the receive port on the LimeSDR Mini. Now, what we'll be using as a signal source today is a Gunnplexer. So this is a fairly primitive signal source, with the microwave oscillator being a gun diode that's just at the back of this cavity here, and we'll be applying around 8 volts to that, and it should generate as a signal around 10.2 gigahertz. There is also a little bit further forward a mixer diode as well, so this is a transmit and receive device, and it found popular use in Doppler radar modules. So you might have had one of these opening and closing the doors in a shopping centre, for example. They also proved incredibly popular with amateur radio operators during the 1970s and 1980s for 3 centimetre band operation. And in fact, they're probably still finding use in that application even today. So what we'll do is we'll sit this opposite the horn antenna, and this is obviously not an optimal configuration. There's no antenna connected to the waveguide flange on the Gunnplexer. There's just the waveguide aperture pointing towards the receive antenna. So if we move over to the software side, we have, earlier we started LMS8001 GUI, and in much the same way that you do with Lime Suite, you connect to the board, and then following which you can either enter settings directly, or you can load an INI file that has all the various settings that you might need saved. So we did that. We loaded settings to configure channel C, and we downloaded these from the GUI to the chip, and we set the we set the VCO to 8 gigahertz. So on the SDR side itself, connected to the LimeSDR Mini, we'll be using GQRX. One of the many nice features that this has is the ability to configure a LNB-LO frequency, local oscillator frequency. So this would be more typically if you had a surplus satellite dish, if you had a parabolic antenna with an LNB connected. But in much the same way, we can configure the same frequency in here that we set our VCO to on the LMS8001 Companion, and then if we start the DSP processing, we can see we've got the spectrum display here, the waterfall below. So next we'll turn the power supply on, and hopefully we should see a signal generated by the Gunnplexer. And there it goes. So this is, obviously it's a free running oscillator. It's not hugely stable. It is mechanically tuned by this screw to the side, and the conditions that we have here are obviously suboptimal as well, by just having the end of the waveguide flange pointing at the antenna. But as we can see, there's a peak here, and if we see where that is, that's coming up around 10.276 gigahertz, or thereabouts.